All right, we're going to discuss the experiment 20. That's the next experiment that we're going to, it's actually the first experiment that we're going to perform. And this is the specific heat of metals. We discussed specific heat in the, in one of the chapters of thermodynamics, and we're actually going to do a virtual experiment using the, using a website. You are welcome. I will share the website with you. You are welcome to conduct this experiment yourself if you want to change some of the parameters. I'm going to go through it once for aluminum and once for copper, and take the data down, and you will fill out the lab report and turn it in. You can turn it in if you buy the ebook. A lot of these, if you have the type of device that you can write with a pencil, then you can turn that in electronically, a PDF of your electronically filled out sheets. If you print the paper, or if you have a hard copy paper, you can fill it out and take photographs or scan it and get a PDF and send it to me. You don't have to mail anything to me. It's all going to be electronic. Okay, so our first experiment is the specific heats of metals. Now, every experiment is going to have this advanced study assignment that I'm circling here with the, oops, let me put up the advanced study assignment. It gives you a discussion on the procedure. After the procedure, you get a table, the laboratory report, and then it ends with questions, and you need to turn all three of those in order to get full credit. If you're missing a section, some people just turn in the data table. That's about 50 points. I mean, if you're going to get 100 points, you need to turn it all in. So these that I've circled: the advanced study assignment, the data table, the where you actually take the data. Let me get to it. Here, the data, and then the questions. So you need those three portions. Now that I'm looking at this TI, we're only going to do TI experiments. We're not going to do any CI. The CI are the computer instrumented, and we're not doing any of those. So let me erase those, and let's go to the discussion. Again, we're talking about the specific heat of metals, and the specific heat. The material's behavior is characterized quantitatively by specific heat, which is the amount of heat necessary to raise the temperature of a unit mass of a substance by 1 unit temperature interval. That is, to raise 1 gram or 1 kilogram of a substance by 1 degree C. So that's what the specific heat is. Well, you need to read the introduction and objectives, and you'll see that they talk about heat capacity. That's a capital C. Heat capacity is a capital C. Oops, messed that up again. The capital C there, the C delta T, that's heat capacity. This lowercase c is specific heat, and we're going to deal with the lowercase c, specific heat, which this equation, the specific heat is equal to the amount of energy divided by the mass divided by the change in temperature. And so we're going to, in the real world, we would use a calorimeter, and the calorimeter itself, well, that's not the calorimeter. This here is the calorimeter. You have to take into consideration the cup and the stirrer, the specific heat of the cup and the stirrer. Typically, they're aluminum. You would have to take those into consideration, but we don't have to take those into into consideration. So you're going to see how the equation changes. So basically the calorimetry is a way you heat one substance up and you cool or have a cool substance. Typically, the cool substance is water, and the heated substance is some metal, aluminum or copper. You heat up the metal, you have cool water, you put the metal into the water, and the change in temperature of the metal, um, the amount of heat that the metal loses should be the amount of heat that the water gains. Now here they have Q metal equals Q water plus Q of the cup and stir. Well, we don't have a cup and stir. This is a virtual experiment. So that's going to change our equation. All we have is the change in Q metal is going to equal the change in Q water. So what is the Q, delta Q metal? Well, that's M, the mass of the metal, times the specific heat of the metal, times the change in temperature. That's the T metal minus the T final. And the water is going to be the mass of the water times the specific heat of water times the T final minus T water. Now, if we solve for the specific heat of the metal, if you just solve that algebraically, you get this. If you solve it with using this equation that's in the box, that includes the cup and stir, then you get this equation, 20.4. Our 20.4 is a little bit different. It's going to be the specific heat of the metal is equal to the mass of the water times the specific heat of water times the difference between T final and the initial T water, divided by the mass of the metal times the temperature of the metal minus the T final. These two will be the same in our equation. So this becomes our new 20.4, and this is the one that you need for this experiment. Okay, and with that, I think I'll perform the experiment, and you'll see. I'm going to go through the procedure, do it for aluminum, do it for copper, and you'll be able to see what we'll fill this out. Okay, I'll have it partially filled out, and you do the rest. Okay.